to yet another class. I'm Dr. B, your chemistry teacher, and today we're going to be discussing percentage water of crystallization. Percentage water of crystallization. So you're going to see percentage water of crystallization. Yeah, we're going to look at percentage water of crystallization. Last time we had looked at how we can determine percentage impurity in a compound. Today we are going to look at how we can calculate percentage water of crystallization in a compound. Do not forget that you have to share this video as much as possible to get other friends, colleagues, and classmates of yours involved in this. Let them be part of what you are benefiting from. So you need to share this video, share it, make sure you share it. You also need to like, make comments, and then to my Facebook page, Dr. B Chemistry or Dr. B Science classes. You have to also need to follow and share as well. Encourage your colleagues to also follow so they can get these videos even at the Facebook page. And then you also have to do what to like and to leave comments as necessary as it is. Now, having understood that, we're going to go straight into what we mean by percentage water of crystallization. Do you know that we have two different types of salts? We have salts that are either hydrated and we have salts that are also anhydrous. Salts that are hydrated are salts that contain some amount of water, and we classify those salts as salts with some percentage of water of crystallization. Now you can either say water of crystallization or you can say water of hydration. So now there are salts that are just anhydrous salts. Those salts do not contain any form of water or crystallization. And today we are going to see how we can calculate percentage intensive amount of certain water molecules that are in certain compounds, especially salts. But what is the relevance of water in certain crystals? What is the relevance of water? Remember that these molecules of water get themselves bonded chemically to these very crystals, to the very central metal ions, which sometimes you will discuss and call maybe copper, for example, which serve as a central metal atom, and then it has this water as being part of the ligands that bond to this particular copper. But the issue is why the presence of molecules of water in certain crystals. Do you know that it is the presence of water in certain crystals that give them the color that they have? For example, copper sulfate pentahydrate. Copper sulfate pentahydrate, which is CuSO4.5H2O. Copper sulfate pentahydrate contains 5 molecules of water of crystallization, and it has a blue coloration. The crystal is blue. It has a kind of sky blue color. So if you take a copper sulfate crystal, you will see that it is bluish in color. And the presence of the water of crystallization gives rise to the coloration that you see. Also, the geometrical nature, that is the shape of most of these compounds, are also contributed by the presence of the water molecules that you see there. So the water molecule presence in certain salts that make them hydrated is not just there for being there, but for the sake of being there, it is there to contribute also chemically and physically to these particular salts or crystals. Now, if we want to take a look at how we can be able to calculate percentage water of crystallization. Now, the first way we are going to look at it is in this form. What if we were asked to calculate the percentage water of crystallization in this salt? Let me just start from here. If we were asked to calculate percentage water of crystallization in this salt, copper sulfate pentahydrate, you must know the molecular masses of these particular elements that make up this compound before you can be able to calculate it. Now, first let us know that copper is 64, and then sulfur is 32, while oxygen is 16. So we have to multiply it by 4, okay? And then water, H2O, is 18. We have to multiply it by 5. Okay, yeah. Okay, remember that this hydrogen is 2, and then this is 16, oxygen. So 2 plus 16 give you 18. You multiply it by 5 because of the presence of 5 molecules of water or crystallization. And then copper is 64, sulfur is 32, oxygen is 16. We are going to multiply by 4 because of the 4 molecules of oxygen, and then we have water 18. When you add this, you should have about 250. Do that calculation yourself. When you add 64 by 32 and then multiply 16 by 4 and then 18 by 5 and put together, you should have molecular mass of copper sulfate, of hydrated copper sulfate, to be about 250. Now, if this is what we have, let us know that percentage water of crystallization, please allow me to write it this way, it's not the conventional method. So percentage water of crystallization is always calculated as the mass of water, the mass of water of crystallization all over what? All over the mass of hydrated compound. The mass of hydrated compound. Yes, multiplied by 100 over 1. So if you are calculating percentage water of crystallization, you must know that percentage water of crystallization is mass of water of crystallization over mass of hydrated compound. And the mass of hydrated compound is copper sulfate, is of course the copper sulfate pentahydrate, the whole of this. And then the mass of water of crystallization is the amount of water present in this very copper sulfate pentahydrate. So it means that what we will have is going to be, the mass of water of crystallization is your 18 times 5, and that will give us 90, all over the mass of hydrated compound is that is your copper sulfate 5H2O is 250. So if we multiply this by 100, so we're going to have 9,000, because 90 times 100 is 9,000, all over 250. So we should multiply, of course, we have already multiplied. So if we divide 9,000 by 250, what are we going to have in there? What are we going to have in there? So you can see the amount of that. So once you multiply this, of course you know that this will cancel this. Is it not so? So your 900 goes into 25. So what you have over there gives you approximately your water of crystallization. So let's say approximately, let's say we have 36% water of crystallization. Okay, let's see, let's say we have that. So because for every 100 you have 4. Okay, so and this is 900, is it not so? So you have about 4 times 9, and that is 18, that's about 36. So you have 36%. So this is how you calculate your percentage water of crystallization. Now in this case, it is because you were given a direct question. You were asked to calculate the percentage water of crystallization in copper sulfate pentahydrate. Yes. So since you already knew that you had copper sulfate pentahydrate, and you were asked to calculate the percentage water of crystallization in this salt, it was easier for you to get the molar masses of these and then calculate them to have the mass of hydrated compound, and then you have the molar mass of the water, use it as a mass of water crystallization. Multiply that by 100, you are able to secure your percentage water crystallization. But what if you were not given the salt? What if you were not given the salt? Now let us look at that. What if you were not given the salt? Now, let's say you were not given the salt. You were given a direct question. Let's say, let's for something a bit easier so you can be able to work with. Let us say you were told that a 0.36 grams of hydrated compound or salt, okay, was heated until constant mass of 0.301 grams, okay, let's say 30 grams was obtained. What is the percentage water of crystallization in the compound? Okay, I just used to write this. I don't like writing like this. It will waste much of our time. But however, if you were given a question, you see that this question is different from the other one. The other one was direct. You were told you have a salt, copper sulfate pentahydrate. What is the percentage water of crystallization? It was clear. But here, you are told that a 0.36 grams of hydrated compound, we do not know the compound, was heated until constant mass of 0.30 grams was obtained. What is the percentage water of crystallization in the compound? Now it's simple. Let's go into business. To calculate the percentage water of crystallization, remember that percentage water of crystallization is given as the weight of water of crystallization over the weight of hydrated salt or compound. That is it. Okay? That is to say, you have a beaker with salt in, okay, and then you have a Bunsen burner with a flame. Okay, now this of course is your water of crystallization, and this of course is your hydrated salt. Okay, so you have a salt which was 0.3, that is, this salt here was 0.36 grams, and you were heating it. There was actually loss of water of crystallization, and the salt after heating got a mass now of 0.30 grams. What is the percentage water of crystallization? That is it. Okay, now if we agree with this, it simply implies that we know the weight of hydrated compound, which is 0.36 grams. Now we do not the weight of water is the issue. So to get the weight of water, or you could just say the weight of water of crystallization, is simple. What we just do there is to get the weight, the weight of water in here is simply going to be the weight of the hydrated compound minus the weight of water. Okay? Or let us just simply say the initial weight minus what? the final or the final weight, or rather the final weight minus initial. Let us put it that way since the figures went that way. So we can just simply say the final weight, okay, your initial weight minus your final weight. And remember your initial weight was 0.36 grams minus your final weight, which is 0.30 grams. This of course will give you 0.06 grams. That's what you have. Now, if this is 0.06 grams, that's of course supposed to be the weight of water. But what is the percentage water of crystallization? That's what we're saying here. So if we now put this back to this question, what you and I are going to have is simple. We are going to have 0.06 grams all over 0.36 grams times 100 over 1. This is because the weight of the hydrated compound is 0.36 grams. That was your starting weight, okay, the initial weight before the hydration took place. So now, after the hydration, after you lost the water, you now have 0.30. So we place this weight of water all over that of this. Now if you multiply 0.60 grams times 100 and divide it by 0.36, you should have something like 16.6%. This is the percentage water of crystallization that is lost. Now that you see, there are two ways you can solve this. Where you are not given the salt in question, you can simply do a simple subtraction using the initial and final weights in terms of the loss of water of crystallization, or weight loss as you make after the salt. Then where you are given the salt directly, you have to use the molar masses and get the molecular weight of the entire compound. Use it as what? The weight of the hydrated compound, and then place the weight of the water over it, multiply by 100. I'm sure that this lecture today on percentage water of crystallization was clear enough. You learned something. You can use other examples and apply this technique, and you could see how simple it is to solve and obtain percentage water of crystallization. It's not having this class with you. Do not forget to share. Do not forget to share. Do not forget to share. Do not forget to get your friends, colleagues involved so we can learn together. Don't forget to like. Don't forget to comment. You can leave your comments. Be polite enough. Even if you question, we'll attend to them. Go to Facebook page. Do not forget to also share. Do not forget to also comment. Don't forget to follow. And finally, don't forget to like. Until next time.